Hello dear students, here I am going to explain projectile motion on an inclined plane. We know oblique projectile and horizontal projectile, and next we have one more called as inclined plane projectile. Here there are two cases. One is we can throw the ball up the inclined plane and other one is down the inclined plane. So let us study projectile motion along the up the inclined plane. For this, consider an inclined plane whose angle of inclination is, let us suppose, alpha. So this is an inclined plane whose, whose angle of inclination is alpha, and throw the ball from a point, call it as a point of projection. So give the velocity to the ball. Okay, here this is called as point of projections, and let us suppose it makes an angle beta, and this ball will move into the air. This projectile will move into the air. Finally it is reaches along the inclined surface after some time. Let us suppose this is an x coordinate and this is something y coordinate. Here initial velocity of the projectile resolved into two components. One component is called as ux component and other one we can call it as uy component. So resolve the initial velocity into two components. One is ux can be written as u cos alpha, sorry, u cos beta because I taken beta angle here, and uy written as u sine beta. And we know gravity everywhere acts vertically downwards, and here this is the ground. So gravity anyhow everywhere it will act vertically downwards. So gravity acts vertically downwards. So resolve the gravity into two components. One is perpendicular to the inclined plane, that is anyhow this angle is alpha because here is alpha. So g cos alpha perpendicular to the inclined plane, and another one is g sin alpha along the inclined plane and opposite to the motion of the projectile. So here acceleration of the body can be resolved into two components. One is along the inclined plane, so that is nothing but minus g sin alpha, and other one is ay perpendicular to the inclined plane minus g cos alpha. Here as the projectile thrown into the air, after some time it reaches a particular point, let us suppose it b, and here this is the highest point. At the highest point we know the final vertical component of velocity is 0. Okay, now let us talk about the vertical direction. So along vertical direction the displacement covered by the projectile is 0. So along vertical direction the displacement covered by the projectile is 0. So from equations of motion, let us use s is equals to uyt plus half ay t square. This becomes 0. Uy t nothing but time of flight, and this is ay nothing but minus ay. So ay t square. So if you solve this one, t is equal to, you will get 2uy by ay. It is like a 2u by g. Here in place of u we can replace uy. In place of g just replace ay. So if you substitute, you will get the time of flight of a projectile to 2u sin beta by ay g cos alpha. So this is the equation of a time of flight of a projectile. Similarly, we can find maximum height. Okay, if h is the maximum height of a projectile, so along vertical direction, again from equations of motions, v square minus uy square, we can write it as 2ays along vertical direction. So anyhow along vertical direction vy component is 0 and ay anyhow it is negative, so s can be written as h. We can write h is equals to uy square by 2ay. It is also similar to like a u square by 2g concept. So in place of u, just we are replacing uy, in place of g, ay. So h is equals to uy, nothing but u square sin square beta by ay, nothing but g square cos square alpha. So this is the equation of a maximum height. And similarly we can find range. Here O to B, call it as a range of the projectile. So range can be calculated by using again from equations of motion. So we can write S is equals to along the horizontal direction uxt plus half ax t square. So S nothing but the range, ux nothing but u cos beta into time of flight and half into ax nothing but g. Okay, anyhow range is decreases in the up the inclined plane, so g sin alpha into t square. Once we substitute t value here, we will get the range equations.